how to make ratios for similar triangles. So what you want to look for, let's say we have two triangles. This is a general thing we can talk about. Let's say we've got two triangles. They look like this. And we're going to call them ABC and DEF. And we want to set up proportions in these triangles. The first thing we need to do is determine which sides are corresponding, which sides link to one another. And the first thing is either we're told these are similar, or we determine through various means that the three angles of the triangles are congruent. So pink equals pink, green equals green, blue equals blue. Once we see that, this is the angle-angle theorem of similarity. We know these triangles are similar. And now we know we can set up proportions. So what you need to pay attention to, it's kind of two ways to look about it to find corresponding sides. Either for a given side, let's say side AC, look at the angles that it's associated with, that it's kind of made up of, the pink and the blue, and the side in the small other triangle will be the one that is pink and blue. So AC corresponds to DF because they're both the pink and the blue side. Or you can look at the angle across from the side, which is probably easier. So the side across from the green angle corresponds. So AC to DF, AB and DE, and then BC and EF would be corresponding. So when you're looking for corresponding sides, you actually pay attention to angles. That tells you which sides link up. And then once you've done that, you can create all kinds of ratios. So you could do AC is to DF as AB is to DE, or BC is to EF. Or you could mix the triangles together. You could do AC is to BC, so basically the green angle to the pink angle, as DF is to EF. So again, green to pink. So there's a lot of different ways to do this, but the key is to find those corresponding sides in the first place. And then once you do that, just be consistent with the ordering. Either put the same triangle in one fraction, or put the same triangle on the top and the bottom. Be consistent. Follow up, what if those triangles are inside each other? It's the same idea. So this is actually often what you'll see on the SAT. So the question about similar triangles, what if they are inside each other? So let's say I had something like this and something like this. Same thing applies. You have to find the corresponding angles or corresponding sides. So let's say we had A, B, C, D, E. We know, for example, let's say these are both right angles. So we'll call those our red angles. We know they both share this angle A, right? Triangle ADE and ABC both have this angle A, so that's the same. And we know, therefore, that these angles, make these blue, must then be congruent. Because once you found two angles are congruent, you know the third has to come along for the ride, because the three angles have got to add up to 180. So what do you do in this situation? It's the same thing. What sides would be corresponding? So I could do AE is to AB. This is the side across from the blue angle, AE and AB, as let's say DE is to BC, so the two sides across from the green angle, right? It's the same thing. Just pay attention to where your angles are and find which ones correspond based on which ones they're across from, or which ones they're composed of. So like BE is across from the green, but it's also in between blue and red. It just depends on how you like looking at it. I like doing it across from the angles. It's usually easier to follow. To learn more about Reason Prep's SAT, SAT subject test, and ACT video courses, go to reasonprep.com/enroll, and you can find the link in the description below the video.